Hope you had a great lunch. My name is Richard Taylor, and I'm here to chat with you about unit testing and raising the value of your unit tests. So appreciate you spending at least one of your sessions this afternoon with me. And actually, I had a pleasant surprise. I didn't know we were actually going to do a live stream, so welcome all the folks that are online. I appreciate you sitting in as well. So as I said, my name is Richard Taylor. I am from North Carolina, actually Huntersville, North Carolina, which is right north of Charlotte, North Carolina. I am pretty active in the community. I'm a full stack developer. I do web, backend, pretty much do it all. Whatever needs to be done, I do. I am responsible for a couple of users groups or meetup groups in my area. One called Modern Dev Charlotte, which is basically geared towards full stack developers. We focus on basically all the technologies that need to come together to actually build enterprise systems. So one week it could be databases, next week it could be a web API. Another week it could be front-end JavaScript frameworks. It just depends on what's going on. I also organize the local Xamarin group, so mobile development with Xamarin and Microsoft's tools. We meet once a month, and obviously we talk about all that goes on with Xamarin. So I blog at We Writing Code, and I tweet quite a bit at Writing Code. So if you want to check some of the things I have to say, check me out. I'm also, so I do have a day job. I'm a vice president of engineering for a company called Century One, which is dressed with shirt and hat. We build software for what's called the Microsoft Data Professional, and it's targeted at performance tuning and monitoring SQL Server. So we build tools around that sort of problem domain, and we're always hiring. So if you're interested or looking for a role, see me after the talk. All right, so show of hands before I kind of get into sort of the goals. Who is using, who has unit testing as part of their development today? Cool. Well, I'm actually pretty excited to see a full room. Usually it's like one or two, and I'm glad to know that there actually are an expert, or at least experts in the room on unit testing. Makes me feel a little better. All right, so define unit testing is one of the goals. I'm actually going to move pretty quickly through that since it sounds like most of the room is kind of up to speed on what that is. Then what I want to get into is exploring some of the unit testing styles that are out there, and then move on to identifying weaknesses in unit testing, and then finally, how do we get more value out of our unit testing? Now, most of what's in this talk is more of my opinion. Some of the stuff you will see, at least you will be familiar with as it relates to some of the styles and things like that, but I want to make sure that you understand this is kind of my experience and kind of what works or has worked for me, and has actually, when I've taught it to others, has worked for them. So, all right, so I'm going to move through this pretty quickly in terms of what is unit testing. Just a couple things that I'd like to point out. Obviously, unit testing, we're going after that unit of work. We want to make sure that it is functioning properly. And then also, just for acronyms, system under test. I'm gonna say SUT, but the system under test. That's what that means. Okay. All right. So, and everybody knows, unit testing. I mean, really, what it boils down to is it's code to test code. I mean, that's really what we're. Okay. So moving right along. So what? Oh, actually, I had a few other. What is unit testing? Unit testing can be done manually, but it's mostly automated. Part of your local build or a CI/CD pipeline, and it should be isolated. One thing to point out is not TDD. It's a component of TDD. But when you hear unit testing, that's not test driven. By that. All right. So more into the meat of what we're going to get into. So why do we write tests? Well, there's a number of reasons, but here are a few. To increase the confidence that the code changes that we're making do not break existing functionality. So if you're like me, I don't remember the code I wrote 6 months ago, right? I'm actually good at remembering the code I wrote a week ago. So, so if you're constantly making changes, iterating over features, functions, fixing bugs, things like that, unit tests are there to kind of keep you kind of sane, right? Make sure you're not breaking anything. Another point on this one also is If you're like me, where you're sort of responsible for bringing up junior devs, uh, having unit tests actually gives them a little bit more confidence in making changes, because the minute they break something, they can actually see it, see the results, and either engage someone, or if they made a change, obviously, and the tests are still working, then they have some level of confidence that the change won't break anything. Find errors early. So if you think about software development and building enterprise systems, there's sort of this sort of pipeline of things that happen. And then when it gets a little bit more complex as you add more and more teams and they're working on different things, but they're working on the same code base. You don't want to find an error right before you're about to ship the software, right? Right before you're about to publish, or if it's on premises, you're about to package it up. You don't want to find an error there. You want to actually find it in the dev cycle, right? You don't want to wait until some manual tester gets to it, sort of towards the end of that pipeline. You want to find it early. So we write unit tests for that as well. To provide some documentation. So this is more intentional. So if you go about creating tests in certain ways, it will actually give you a little bit more document, or at least a little documentation on actually what business rules that are a part of a component or a class, what the software actually is supposed to be doing. So yeah, it will actually provide some documentation, and then also facilitate refactoring and software design. So testable code, which a lot of you have heard, at least heard that term. In order to create testable code, there's some basic principles in how you design that code actually cause it, or at least allow it to be testable. And of course, once you have those tests in place in that testable code, there's some benefits to it in terms of how it's structured, how you perform maintenance. It's just a better environment, at least from a management standpoint, from a coding perspective. So let's get into styles. So there's a couple styles in unit testing. This first one, output verification. And basically what it boils down to is the system under test, so the SUT, we're going to give it inputs, right? And we're going to test for expected output. And when you think about all the types of, or at least all the styles and types of tests, and we'll get into a little bit more of that in the talk, when you think about value and kind of what that brings to what it brings to the table, this one, in my opinion, is the highest value, right? Because you have a lot of control over what's going on. You know the system that's under test, you know your inputs, and then you have an expected output, right? So it has its highest value. And we'll also see another reason why it has a high value, and I'll get to that on another slide. State verification. So state verification, the way that works, or at least the concept, is that I'm going to actually call or use the public interface of a class, and let's use that as an example. And then what I need to take a look at as a result of that call is what is the state of the object. Maybe there's some properties that are public on that object that I need to test for certain conditions. And this is where state verification comes into play. It could be a single data point, it could be multiple data points. It depends on that system under test. It does have a lot of high value, okay? Reason why I kind of mark this down just a little bit is because typically it's multiple values that you're looking for. Maybe it's multiple property values that you're testing. And so it does have value, but I think, at least in my opinion, the output verification style is probably the most valuable. All right, so the last style that I want to cover, collaboration verification. So what we're doing here is we're providing the system under test, the SUT, with some known inputs, using its public interface. And what we're testing for in this scenario is how did it react with its collaborators. It could be as simple as with that input, did it call the proper classes in the right order or methods in the right order based upon my inputs? And that order might change depending on the input. So you're basically, what you're looking for is how is it working with the other parts of the overall system, and is it doing it properly, or at least as expected, okay? It is the least value, in my opinion, because it's brittle, right? You have these other collaborators that could have code changes that might impact that actual test. There is some value there, but again, it's brittle, and at times it can be difficult to maintain. So what is a valuable test? Well, first point, a valuable test has a high chance of catching a regression bug. Okay, back to that first point I made, where you want to make sure that you're not breaking anything when you're changing code, right? When you're refactoring. So yeah, high chance of catching regression bugs. It also has a low chance of producing a false positive. That sort of speaks to the brittleness, right? You want that test to be fairly reliable, actually really reliable. I've been in situations where we've had tests that were so brittle that the team just kind of ignored the test because they were sort of chasing things, right? And that can happen very, very quickly. And then, of course, the value of your test and test suite starts to degrade. It provides fast feedback, right? So, most developers that I've worked with, they're not patient. So they're not going to wait for, a set of unit tests. They're not going to wait an hour for your test suite to run, right? And of course, that's not very efficient. So it needs to be fast, very fast. So what can cause a unit test to lose its value? Very, very good. So test names that do not effectively describe the test. That's one. Being intentional with test names, and we'll talk about some options and how we organize our tests. That adds a lot of value, particularly when you're in that iterative phase of building code, testing things, and actually fixing bugs and so forth, particularly large systems. The naming convention is important because you don't want to kind of get lost in trying to find out what's going on, where's the test, how is it related to the code I'm working for or working with. So we need to have effective names. Complicated unit test code. So a good example is if I have to write 20 lines of code to kind of get things set up before I can actually run the test, then there's something going on there that we might want to take a closer look at. And of course, who wants to maintain it, right? Who wants to maintain yet another set of code related in addition to the features and functions of your system that you're. So we don't want it to be overly complicated. And then testing more than a single unit of work. So this is one that bites a lot of people. If you have a test that fails, right, and you're testing multiple units of work or multiple areas, what's wrong? When a test fails, what's wrong? Well, you have to kind of go and look at multiple places, right, to try to figure out what's going on. That starts to be a burden, and it starts to lessen the value of your test. And then brittle systems, right? So a brittle SUT or brittle test, and basically will basically create work for you when you're actually changing that system under test. So you want them to be sort of as flexible and not as susceptible to code changes that you might be making in your system. A good example is if I'm going in to fix a bug, and the bug I already have established like the business rules and what's supposed to happen. If I go in and fix the bug, you really don't want to, and the test was working before and somehow something went wrong, you really want to focus on the bug, not the bug in the test. Unless you're fundamentally changing maybe the public interface on the class that you're testing, the outputs of the method, or just the architecture of the system. That's when you start to get into like test maintenance. But if I have a known set of inputs and I have an expected output, and for some reason some code change caused that to fail, and I need to go update that, I really don't want to have to dig into like the test. The test should still work. The business rules are there, right? And of course, difficult to maintain. That kind of continues on that sort of that same theme. If things are so tightly coupled, or the test in a way where you could find yourself actually spending more time on your test and actually building value for your customers, bug fixes, and actual new features. And I mentioned this before, being unreliable. Basically, if your team doesn't have a lot of faith in what you have in terms of your test, then they'll just get ignored, right? They bring no value to the table. So those are some reasons why tests can lose value. And then slow. I mentioned that as well. Won't wait around for those, or might even avoid running them. All right, so how do you make your unit tests more effective and more valuable? Well, make them clear, simple, and readable, right? It shouldn't be that hard. You should be able to see what's going on with your test pretty quickly. Make sure they have high value. All those points that we mentioned before on value, make sure you cover those. They're flexible, right? Your system's going to be changing. We want to make sure that if you need to make test changes, then they're minimal, and they can handle in terms of changes. They can handle them quite well without breaking and requiring a lot of maintenance. So, clear, simple, and readable. How do we deal with those? Well, make test names consistent, right? Utilize a naming convention. Now, there are tons of them out there. There's one that I'm not going to say it's my favorite, but it's one that I use quite a bit. Use a 3-part naming convention. Okay, and what that means is, here's an example. So we have a unit of work. That's sort of the first part of the test name, right? And then after that, we know our inputs, right? So we're gonna the initial condition. What's either going in, or what's the state of the system of the test, or the system of the test, or the inputs going into whatever we're testing. That's our initial condition, and then expected results. What's the output? Okay. So what does that look like? Well, for one, if you are trying to find out, find your test, look in your a Test Explorer in like a Visual Studio or something like that, you can easily scan and search. It's pretty simple to find things. It groups together tests in those actual unit testing views. Like for instance, Visual Studio, we'll see where you can look and you can see how it's organized. I can see, here's the unit of work that I'm testing. And it's all organized, nice and neat, and it kind of keeps things together. And it provides some insights into the business rules. So, for example, if I were testing, let's say a certain, well, here's a good example. So, I'm testing an add function. Let's keep it simple. I'm testing add function, so that's my unit of work, add. And then my inputs are 5 and 10. And then my expected result is going to return 15, right? That's very descriptive, and I can understand what's going on in terms of behind the scenes. What's the business rule? We'll see some very good examples when we actually switch code. All right, so test suite should be organized. So the naming actually works quite well. When we look at Visual Studio and Test Explorer, you'll see how just by using a naming convention, the actual organization happens by default. There's nothing extra that we need to do. Don't repeat yourself, right? That's pretty obvious. So we do that when we code. We should do the same thing from a testing perspective. And then descriptive and meaningful phrases. So it can get a little wordy, but that's okay, right? Because the next person that comes along, even if you're that next person 6 months from now, you want to be able to read whatever the test name is and kind of understand what's going on. Follow a distinct pattern. And most of you are familiar with unit testing, so you're familiar with this, right? You start with your arrange, right? And then you take action, and then you do some assertions, right? So that sort of an organization in all your tests kind of keeps things clear and simple. And then focus on high precision, right? So test one expectation per test, right? This kind of gets back to keeping it simple. You understand the inputs and outputs. There's no confusion in terms of kind of what happened. You want to stay focused and test one expectation per test. multiple assertions. So, kind of folks go kind of back and forth on this one. It depends on the situation, right? So a good example, if we're doing, we're using state verification as sort of the style, right? Well, there might be a couple of data points that, let's say it's a class and has some properties, there's a couple of data points that we might want to test as a result of the state once we exercise that unit of work. So that's perfectly fine. That's okay. But if you get into situations where you're doing a bunch of assertions on like multiple objects that are like totally unrelated, what happens when that test fails, right? Is it telling you exactly what's wrong, or do you have to spend a lot of time researching, trying to figure out? Well, yeah, it failed. Now I've got to step through the test and see, what happened. I mean, it gets all complicated. You shouldn't have to do that. If your test fails, it should tell you exactly what's wrong, right? And so multiple assertions, while they're okay, you just have to be careful with them. And then, of course, the test should point to the precise location of the problem. Sort of the point I was making before, where you don't want to get in a situation where a test fails and I've got to go look over here, I got to go look over there. That just becomes more of a pain than anything. And of course, the value of that test is questionable. Okay. So high value. Well, you want to focus on testable code. Use dependency injection to provide your dependencies, right? So this is sort of a way of creating a system, obviously, that's testable, and this kind of goes to that point where if you're doing unit testing and your code is testable, that sort of aids in basically being able to better structure, better maintain as you move your systems forward. And dependency injection, obviously, is one way to focus on testable. Avoid new in your methods. So if we're focusing on testable code, if you have, let's say you have a method call, and inside of it, you're not using dependency injection, you're newing up another object, now you've just created dependency on that other object. And let's just say we're working on a larger system, someone else is responsible for that other object, they make changes could actually impact your code, right? So we want to avoid using new when we're actually creating our testable code. Avoid global state. Now, this is more preference. There are situations where global state makes sense, but when you're focusing on testable code as part of the whole problem that we're solving, we want to avoid global state at all possible. And then be careful with static methods. So this is something that I've run into several times in my career, where we use static methods throughout a huge code base. But what happens is when you want to test that code base, well, you almost have to run the application, right? You have to create everything before you can actually start testing. And in very large systems where they rely on a lot of static code, that becomes a problem. So be careful with that. I'm not saying that you shouldn't have it, just be very careful with it when you're focusing on testable. And continue on. When you can, use seams to actually help with the testability, right? So what we want to do here is we can go ahead and new up the dependency, but then make sure that we can override it so that it gives us, okay? A good example around testing, you guys are mostly familiar that test, or at least when you are testing, things need to be deterministic, right? So if you have a situation where you have a class or method that you're trying to test, and there's an object that you don't have a lot of control over, then automatically that test for that method is going to be susceptible to whatever, and actually it can't be deterministic, whatever goes on with that object. And if it's a third party or if it changes, then your test is going to fail. A good example that I use in other talks is I have a method in a reference app where we use system time. And based upon system time, the logic in the method changes. And it's used to calculate a discount to kind of give you some context. And if certain things happen in certain parts of the day, then you get a certain discount. That's what it calculates. Well, it works logically. If you look at the code, you run it, it works. And you sample it at every at every, I guess, measurement of time when we're actually adjusting the flow, it perfectly works, but you can't test it because the tests now are dependent upon the time of day, right? And depending on when you run a test, depends on if the test is going to pass or fail. So you have to be a little careful with newing up objects, but in this case, we can actually get favorite composition over inheritance. So dependency injection, obviously that. Pass in your, instead of inheriting from other objects and its methods, and not go ahead and inject what you pose the class as opposed to actually using inheritance to actually get the, and then apply solid principles. We can talk all day about solid principles, but if you look up what that means, it's all about building software in a way where it's maintainable and works very well with large systems, large teams. That so when we're focusing on testable code, solid principles make a lot of sense. Back to high value. So test code that has high risk. So that's pretty important, particularly when it comes to complex workflows. Obviously, you want to make sure that at least those are covered by your unit test. We also want to make sure that unit test is going to cover all calculations, right? So that's back to your the test where you know your inputs and your outputs, some sort of calculation test against. You definitely want to make sure all of those are covered when writing unit tests. You want to minimize what-if scenarios. And so what I mean by that is think about when you're testing edge conditions, right? We write code, for those that are experienced software developers, we write code and we try to account for edge conditions. Well, it's sort of the same thing, right? Let's say you need to handle negative numbers, figure out what to handle zero, and you need to handle obviously positive numbers. That is a simple example. Well, your tests need to kind of follow that same path. You want to make sure that, let's say, that method is handling those conditions properly. But you don't need to go any further than that, right? So if you can ascertain that, hey, if the method works for a certain range of values, then and it's safe to assume that that range works for a broader range, then zero in on just that range. That should minimize the what ifs. There's no value in having a test it's no value of having a test that's working on a certain range that's assumed it can work on another range. Having two sets of tests with very little value there. Logic doesn't change. Cover all your business rules. This is basic. This should be a requirement, right? If you're not covering your business rules in your system with unit tests, you're really taking on a risk. Make sure that all the business rules that are part of your system are covered. Cover your happy paths and your non-happy paths. So those scenarios where my function in that case, or method in that case, where it returns a value, right? How you get there and what it returns. Obviously, you want to test for that, but also test for something else. What happens? I expect an exception to be thrown when a negative number is calculated, right? Let's just say that's my business rule. Well, you want to test for that, right? You don't want to leave that one hanging versus the happy path. And then avoid testing things that the compiler would do. So I've actually seen we had a method that returned an integer. This is a method that returns an integer, and then an assertion was the type return an integer. Well, in languages like C# and some of the statically typed languages, there's no need for that, right? Because the compiler is going to complain before you code, right? Now there's an exception. If your method is returning an object and you have logic behind that to determine what type of object that gets returned, then you might want to write unit tests for that, right? And actually test the type, okay? Also, writing unit tests that actually test like text. Yeah, there's not a lot of value in that. So let's talk about flexibility. Maximum of 1 mock per test. Sometimes this can be achieved, sometimes it can't. This is just more of a guidance. This is not a hard and fast rule. This is more of my opinion. Maximum of 1 mock per test. Try to, you're looking at your test suite, fewer than 10% of your tests have mocks. All right, try to strive for that. Again, it may work, it may not, just depends on the problem domain and the system that you're working on. This is pretty hard to do, but don't test private methods or anything related to that. It should be covered by some sort of public method call, right? If you're dealing with situations where you have methods that you're making them public so you can test them, you're exposing implementation details that you don't have to. So be careful with that, right? Don't force that on, don't force your decisions on whether or not something should be private or public based upon how you want to test. Build your public methods, and if there's private methods that implementation details are part of that class, make sure you can exercise them via the public interface or the public method. Test by scenarios rather than methods. So this is a pretty good one too. So as devs, most of the time, we try to go into the details. We try to go into them quick. We go straight to the methods and test those. Step back for a second and actually consider adding tests around some of the scenarios where certain things need to happen. So a good example might be well, here's a good example. So let's just say I have a workflow that requires, I take some input, I require, let's say, database access and integration test. I'm not going to get a database call. I'm going to do some calculations, and I'm also going to then create a new object and return. There's a lot of things going on there, right? And we should test each individual one, right? But step back for a moment and take a look at that and say, well, what's the scenario? What's happening here? Why are these things called in this? You should try to put tests around that as well. Sure that things are working, like that collaboration verification, working like they expected to work, things are called in the right order. Go for test scenarios as well. All right, so before we get into the resources slide, I'm gonna switch over to some code and we'll take a look at some of these. All right, so before I start walking through some code, are there any questions on any of the stuff that I covered so far? Yes, sir. It's just more of keeping things simple, right? And as I said before, it's more of an opinion than anything, and more of a guidance. It's not a hard and fast rule that thou shall only have 1 mock per test. But as you start adding more and more, it's more of a sort of a check, like a smell. Like, wait, let's step back for a second. Let's see exactly what's going on here. Can we break it down a little further? That's more guidance than anything. It's not a hard and fast rule. Okay. Yeah. Yeah, and my response to that will be that definitely can happen, but take a closer look. Maybe you can go a little deeper and focus a little bit further down in sort of that dependency chain. Is basically where that comes from. I'm not saying eliminate that test. I'm just saying that try to strive for that. But if it's impossible, it's impossible. But also, hey, can I add additional tests that are more targeted? Maybe what I'm trying to do is too large. That's really all that comes from. Okay. Any other questions? Yes, sir. No, I don't think that's necessary, personally. I think there's a point of diminishing return when you're going for 100% code coverage, in my opinion. I don't really actually subscribe to any hard number, but if you're spending more time, and I guess I'm coming at it more from a a software delivery standpoint, all the things that are related to building software and actually shipping it. There becomes a point where trying to strive for 100% code coverage doesn't really return a lot of value, and so you have to make some hard decisions. If you can get there, you can get there, but then of course, what does that mean for maintenance? What does that, how does that impact your development cycle? Am I spending more time trying to maintain 100% code coverage rather than delivering features and functions or bug fixes to my users? And that's sort of my opinion on it. Yes, sir. No, we don't where I work. So we have two sets. We have actually three code bases. We have our main code base. That's our main product. Has been there for 14 years. It's a ton of legacy code. I could probably take my entire team and spend 2 to 3 years refactoring it to be testable. And that's just not something we can afford from a business standpoint, right? So we have to make choices, right? So everything that we do every day is not testable. But then we have new code bases that we're working on the next generation of our software, where test-driven development and testable code is basically the rule, not the exception. Because now we have the opportunity to go into that. I'm not going to say a right way. I'm just going to say a better way. Okay. And in a lot of those cases, we use TDD. Yes, sir. Right. Yeah. So for me, yes. But we don't require anyone on our team to use TDD all the time. Right. I do it. There's a few others. The key for us is testable code and associated test. Now, how you get there from my team's perspective, it's totally up to you. If you want to do TDD, that's fine. If you don't, that's fine. Just as long as the end result, the outcome is we have testable code and the associated test, right? And TDD, it works for some, but it doesn't work for everybody, and it doesn't work in every situation. It's a tool that can be used, but you don't have to use it in every scenario. You're welcome. Any other questions before we get into code? Okay, cool. All right, so here's a little app that sort of demonstrates some of the concepts that I was referring to in the talk, or on the slides. So here's, oh, that's right, I need to kill PowerPoint, at least the presentation part. Okay, cool. You see the code in the back. Awesome. All right, so tomorrow I'm doing a talk on Xamarin, and actually this is one of the reference apps, but it's just to set a little context. It's just a simple to-do application, and it can create, you can create to-do lists and all that sort of stuff. And so at the core of the app is this thing called a to-do item. That's what we're looking at right now. This is the class. And when you instantiate a to-do item, this is right here on line 29 is actually the constructor. And the constructor does one thing. It actually it assigns a GUID to the to-do. Okay. Pretty much that's all the business rules for that business object. Okay. So I want to create a test for it. So what do? Well, I'm using, well, actually, explain just a little further. So what you see here in terms of sort of the overall architecture, it's onion architecture. So all the business objects are sort of at the center of the universe, and everything refers to it. So this to-do item being a business object, it doesn't have any references, anything like that. What's so cool about taking that approach is part of it's testable, right? It's independent of anything else. It takes no dependencies, so I can just new it up whenever I need to new it up. If I want to new it up in my testing framework, I new it up in my testing framework, and it has no dependencies, right? So the business rule is one thing. When the constructor fires up, it actually assigns a GUID to that to-do item. So how do I test it? Well, it's a very simple test, right? And let's take a look at line 10 where you see the naming convention. Create new to-do item. So that's my unit of work. right? That naming convention that I mentioned before. Create a new to-do item. And then my initial condition is new to-do item, right? Starting afresh. And then my expected result is the ID is a string, right? So I can read that. It's very, you can see what the business rule is just by reading the name. Very descriptive. I'm not gonna say simple. It's wordy, but anyone coming along today, tomorrow, 6 months from now can understand that. And so here are the sections of my my test, right? So I'm going to arrange, which basically I'm newing up a to-do item, and then I'm going to actually my arrange and my action are kind of one and the same in this case. And then I am asserting that the instance type is for the to-do item ID is a string, right? Now that works. That's good. But am I really testing that, right? The answer is no, because if I change the logic in the code, it's not a it's a GUID, it's not a GUID, it's something else, it's just some random string, that test is still going to pass, right? So here's a better test, right? Now this one here is instead of testing for the type, I'm actually saying, okay, well, it's not null, right? And then I'm saying, hey, it's got a length of greater than 0, right? So that gives me that's a little better than the original test. Now what I can also do is if I wanted to, I can actually extend this or add another test and actually test that it truly string actually truly came from a probably the best, right? But you can see it's pretty simple, very descriptive name and what it does, right? So here's another example. Take a look at the view model. Just a little background in Xamarin. The typical way of doing things is sort of like done with WPF. You basically have view models. MVVM is the design pattern. And it's similar. You use a similar thing with most of what's going on with Xamarin. So here's a view model, and this view model, what it does, if you take a look at the constructor, it takes a data store, something that implements the to-do item data store, right? And it assigns it to a private member variable. And then there's some methods on it, and one of the methods is load items async. So basically what this view model does is it actually supports the do app by querying the database and listing all the items you have in the database. Okay? That's what it does. So how am I going to test that? Well, here's some examples. So here's one simple test. Line 12. The first part of my name is retrieve list of tasks from DB, right? That's my unit of work. And DB, my initial condition. So I'm assuming that there's one in the database, right? And then the result is, or expected result is, there's a list with one task. All right, now, here's where it gets, I don't want to say tricky, but have to sort of think about it for a second. Let's say we included the real database test, right? Well, that test will work if there's only one item in the database. But if there's 0 or multiples, that test will fail. So automatically, it can be, depending on what database I'm using, and particularly if it's a live one, then it's non-deterministic, right? Because I can't control the data in the database. So this is where the concept of mocking comes in, right? Now, I didn't include a mocking framework in this solution because I wanted to keep it simple, but there are mocking frameworks that you can use. But in this case, I just built a class. I called it mock to do item database. And you see, what it does is it actually, when the constructor gets called, it actually adds an item, initialize DB. It adds an item to the database, one item. and I can control the values that go into the database. So I can do a number of different tests. Okay, now I've made that deterministic in my test because go back over to test itself. You see, I'm newing up the mock and passing it rather than the actual database, right? In this case, it's going to take, as we saw in the view, it takes an object that actually implements I to do item database, which has basically it's an interface. And in my class, you'll see here, I'm actually the I to do item database mock class, so I can actually substitute, right? So my test, I'm going to substitute it. Now it's deterministic. Now I'm going to actually the test, and I can run the test reliably. So now the test, if we look at it, basically it news up a list page view, or page view view model. I'm sorry, list task page view model, and then it runs a load item AC right off the view model, and then I'm asserting that that's a simple one. I'm asserting that there's one. But I can do all kinds of other things too. I can, if there's some kind of ETO or something that's happening, that it's actually hydrating an object, I can actually test to make sure that the values got hydrated properly based upon controlling the actual database that's required for that. And lastly, got one other example from a view. So when we want to create a new to-do item in the app, that's construct. We use a create page view model that's wired up to the UI, and it takes a to-do item, and then it takes an object that actually implements I to do item database. It sets them to a couple private member variables, and then there's all sorts of things we can do. We can add, we can load, we can delete, we can set due dates, etc. So how we actually set up a couple of tests for it. Here's one here. Before I expand, you'll see it's add to do item to database, and that actually is the unit of work that I'm doing. I'm going to add and I'm going to retrieve, right? Which actually in effect is testing whether the add was successful. I probably could rework that and say added to item today. But you got to get the point, right? And then the initial condition is that I have a new to-do item, and then the expected result is new to-do item and view model have the same properties. Okay, so when I store it in the database and I retrieve it, when I inspect that object and inspect my view model, everything should line up and should work or should match. So here's the code. So there's my new to-do item. Remember that is it takes no dependency, so I can new it up anytime. I'm setting some values. There's my mock database. Here's my create page view model that I'm testing. And here's a to-do item I'm sending in that implements it. To-do item actually implements that interface that's expected. I to-do item. And then I'm also passing in test data store, which is I to-do. All right, so from here to here, basically the range step, right? And then these two items, I'm going to add the item, and then I'm going to load it based upon. I'm going to load it based upon an ID, and it's actually a known ID because I newed it up here. And then I'm going to assert, hey, is the ID on the item that I retrieved matches the ID on so forth and so on for due date and priority. And so you see how that one works. And then here's another example where I'm adding a to-do item to the database and I'm deleting it. It's a new to-do item, and then I have a deleted to-do item as my expected results. You see the arrange section here where I'm creating everything, and now I'm adding it, then I'm deleting it. And if we look at my delete method on my view model, you see what happens is it's an async call, but the end result is that I get a task of bool, and I wait it over here, which gives I test with. So that's how I'm testing that. So as you can see, the naming convention is pretty descriptive. The other cool thing is if I go over to Test Explorer, take a look. By using that naming convention, I can see a few things. So it's broken out by the project, right? But then I can actually see, if there were multiple to-do item tests, I can actually here. So here's an example. There's my one. But if I had others, delete a to-do item, or if there's other business logic out here. And for each of the view models, you can see it's nicely organized. So by default, by using that naming convention, I get some organization around tests to help me find things when it's broken and help me all in my development process. All right, so wrapping up. So if you want to take a look at the code, play around with the code, it's at that GitHub. Actually, I merged it into the main branch and got rid of the testability last night. So if you pull down the develop branch, it'll have all of what we see. From a unit testing perspective, there's a couple resources. There's a great article at that link, how to write testable code and why it matters. It kind of fits in the overall picture of unit testing and getting value out of your test. And then I'm a fan of Pluralsight, so there's 3 very good unit testing courses that are there, starting from building from scratch to actually doing advanced testing. And then 2 great books, working effectively with legacy code and beyond legacy code. And then testing frameworks. I use mostly MS Tests, so there's a reference there. There are other options in unit and X unit as well. They all have their pros and cons, and some have features, some others that others don't, etc. You sort of just pick which one that works best for you. But they all help you. Okay. All right. That being said, any questions? Covered value of a unit test. Oh. Yes, sir. Yes. The one that I use is mock, MoQ. That's the one I use for .NET. There are others, but that's the one I mainly use. Yeah, that's pretty good. Any other questions about testing in general or value problems you're having with test? So do some of you lead developers? So all of you are like individual. Oh, you have trouble with your developers writing tests? Yeah. Okay. Do they hard time seeing the value out of it? Okay. Yeah. Right. Yeah, we have the same trouble too, particularly like developers that are coming right out of college. They don't stress a lot of that, and I guess from their perspective, it's just more code to write. But that one time when it kind of saved their bacon, then it's like they're sold, right? How about managers that are not, let's say, fond of spending time on unit tests? How many people are dealing with that one? Yeah, they don't. Yeah. So it took me a little while to actually figure out that conversation with that C-suite person. And what I was able to show was the cost, right? I asked for just a sliver of resource to actually use a team and to have them build out tests, and at least from a feature bug fix perspective, like raw output came back just a little. But then once the suite actually got mature and they were actually able to deliver faster, and they would actually show that, then that's actually how I got the C-suite person to actually get on board. It's like, yeah, there is some value to this. Yeah, very similar argument. Now I have not figured out how to like in a consulting arrangement. Yeah, I haven't like having the customer. Yeah, I haven't cracked that one yet. So I might ask you a few questions about that. Anybody else having the challenge with like convincing like their C-suite people or anybody responsible for from a unit testing perspective? So I take most of the room. Since you raised your hand, you're sold. Like unit testing is the way to go, right? Okay, cool, awesome. All right. Well, if there aren't any more questions, I appreciate it. Oh, I'm sorry. Yeah, that is a valid point. So I'll just repeat it. So what he was saying was that having that visual feedback, so the execution of your test suite as part of a CI/CD pipeline, and being able to convey that to either customers or other members of your team is also a valid and valuable way of kind of getting people on board from a unit testing perspective. So. Awesome. Well, if there aren't any additional questions, I appreciate it. Thanks for your time this afternoon. Oh, I'm sorry. I'm sorry. Good question. Good question. Um, so the way we work is basically if it's an individual developer contributor to like a task, right? Then they're responsible for both the feature, function slash bug, and the associated test. Um, if it's let's say, so we work in teams. So we have teams of, could be up to 4 or 5 developers. They may decide, one may go off and do something, 2 may work on something else that might be a little bit more complex. So they may decide on how they might divvy it up. The end result is that everything that's particularly new development, everything is testable and has associated tests. And how we check that is we use a PR process, just like GitHub, and we do that internally. And basically we will reject the PR if they're not in the associated test where we expect them. And then we also have some other metrics that we run when we're looking at the code base to kind of see where we are, and if we're creating gaps between delivery and test, and we'll take a closer look at that. So it really depends, but it can be a collaboration, it can be that individual person. It just depends on the situation. Are you doing something different, or you splitting it up, or? Okay. Yeah. Yeah. What I try to do is, particularly from like leading developers, is I try not to be as prescriptive about those things. It's more like, here's our objective. You guys figure out how you work together. And I've seen various ways of dealing with the building of the test. What we won't allow though is all the tests going to one person, right? Like, person becomes the tester, or the what's called the SDAT. That we have that role, but everybody's responsible for testing. Kind of what we try to push. There's a question. Yeah, so we don't have anything automated. It's the way it works with us is we do PRs, and the PRs go to an entire team. Meaning we have Scrum teams or feature teams, but we have a bigger group of like 50 people, and it just kind of goes in a pool, and everybody sign. You have to have 2 people, depending on the change, it might require a lead to actually do the review, or at least be a part of the review process. But it's all manual, and you see all the notes when they reject it, you're missing test, or whatever they're rejecting it for. But testing is one of them. Oh, and the other thing that we do too is that when we're in sprint planning, every PBI and every bug when we're discussing that to pull it into the sprint. We added a little box that's required, and we use our Azure DevOps now, but we use that. We have a little box called testing strategy, and it's required to be filled out. And then there's a person on each team that's responsible for making sure that everything, not that they're doing the testing, but everything that comes out of that team from a sprint by sprint basis has a test strategy. So that field has to be filled out. So they can't really go any further until can't close the PBI out of bug unless they documented how we're going to test this, what's included, what to look for. But it is manual, fortunately, except for that required field thing. So, all right, I think I'm out of time. I appreciate it. Thanks so much for spending the afternoon with me.